In this video, I'll talk about the pressure volume work. Pressure volume work is one form of mechanical work. How do we compute the amount of mechanical work done to a system? Very simple. You need to multiply the force exerted on the system with the distance this system has traveled along the direction of the force. How do we compute the pressure volume work? We use this equation. The amount of pressure volume work is equal to negative P external times delta V. P external is the external pressure the system feels. Delta V is the change of the volume of the system. So this equation can be a little confusing. Remember, we have a negative sign here, and then this is the pressure of the surroundings. This V is the volume of the system. For simplicity, we usually consider cases in which P external is approximately equal to P, and then we can simplify this equation to work. The pressure volume work is equal to negative system pressure times the change of the volume of the system. Here's the proof. Let's look at this diagram. This is a gas contained in this chamber. It's about to expand against a piston, and the piston is going to travel by this distance, delta H. So we have an initial state here, we have a final state here, and you can tell the volume increases in this process. And the change of the volume is simply A, the cross-sectional area here. So this circular area multiplied by delta H, the distance this piston has traveled. So work is equal to negative F times delta H. This is the formula for mechanical work. Why negative sign? Remember, the gas is considered the system we are investigating, and during this expansion of gas, work is done by the system to the surroundings. Therefore, the system loses energy, and then we define this work of the system to be negative. That's why we put a negative sign here. If you are talking about work of the surroundings, then it's positive. Again, it's because, work is done by the system, which is the gas, to the surroundings. Therefore, work of the system is negative. Work of the surroundings is positive. Now let's look at the work of the system. It equals negative force times the distance, delta H, and the force is equal to pressure times the surface area, which is A here. And then we combine A and delta H, because A is a constant. A times delta H is equal to delta A times H. We can move this constant into this delta. And then delta A times H is simply the change of the volume of the gas. And then we obtain this equation for the pressure volume work, which is negative pressure times the change of the volume. Remember, when delta V is negative, that means the system is compressed. Work is positive. The surroundings does work to the system. When delta V is positive, the system expands, and work is negative, again because the system loses energy when doing work to its surroundings. What if the system volume is a constant? It's called a isochoric process. This means constant volume, and then we plug in the value of 0 for delta V, and then we can tell the pressure volume work is exactly 0. What about the pressure volume work of liquids and solids? It's approximately 0 under all circumstances, because delta V of a liquid or a solid is almost always negligible. you can try to change the volume of a liquid or a solid. You are not going to be able to observe the volume change. So one more thing, you will learn this in upper division courses, for example, physical chemistry. Work is zero if a gas expands against a vacuum, because no work can be done to a vacuum. Therefore, you will see that this equation, work equals negative P external times delta V, is a more accurate equation than just negative P delta V, because in this case, P external is zero. P is positive. So this equation will give you the correct value of work, which is zero. Now I'll give you one example. Let's say a gas expands from 2 liters to 4 liters against a 1.0 atm pressure. We can compute the amount of work and work surroundings. First, let's use the non-SI units, liters and atm. So work is equal to negative P times delta V. We assume this P is equal to the external pressure, 1.0 atm. We plug in the value here, and then delta V is the change of the volume of the system. In this case, it's the final volume minus the initial volume. The result is very simple, negative 2.0 atm liters. However, neither atm nor liter is an SI unit. Now let's use SI units. 1 atm is equal to 1.013 times 10 to the power 5 pascals. 1 liter is 1 decimeter to the power 3. 1 decimeter is 0.1 meter. So if you have 0.1 to the power 3, you get 10 to the power negative 3. So now let's compute the amount of work again. It's negative P times delta V. We plug in the pressure in the SI unit. We plug in the volume change in the SI unit. The result is negative 200 joules. What about the work of the surroundings? The work of the surroundings is always equal to negative work of the system. So simply we change the sign. We say work of the surroundings is positive 200 joules. Again, it's because the system is doing work to its surroundings. The system loses energy, therefore work is negative. The surroundings gain energy, therefore this value is positive for the surroundings. Remember, pascals and cubic meter are SI units, and then we are confident that whatever numerical value we get in the end, it's going to be also in the SI unit. In this case, it's a joule. Unit conversion. 1 pascal times 1 cubic meter is equal to 1 Newton divided by meter squared. Again, 1 pascal is equal to 1 Newton force exerted on 1 meter squared area. So this is pascal. And then multiplied by cubic meter, and then we can combine this two. The result is 1 Newton times 1 meter. And then 1 Newton is 1 kilogram times meter divided by second squared. This is the SI unit of mass. This is the SI unit of acceleration. So in the end, we have 1 pascal times 1 cubic meter is equal to 1 kilogram times meter squared times second to negative 2. Again, this is simply 1 joule. So what about 1 bar times 1 liter? 1 bar is 100,000 pascals. 1 liter is 10 to the power negative 3 cubic meter. Therefore, 1 bar liter is 100 joules. How about 1 atm liter? 1 atm is 101,325 pascals. And 1 liter is 0.001 cubic meter. You do the math, you get 101.3 joule. And you can tell that 1 bar liter is close to 1 atm liter. And again, 1 atm is equal to 101,325 pascals or 1.01325 bars. Now let me give you a practice problem. A gas now is compressed from 7.5 milliliters to 5.1 milliliters. The external pressure is 2.0 bars, and you may assume the pressure of the system is equal to the external pressure. Now calculate work and work surroundings. Here's a little bit of help with the units. 1 milliliter is equal to 0.001 liters. Is equal to 10 to the power of negative 6 cubic meter. This is because 1 liter is 10 to the power of negative 3 cubic meter. 1 bar is equal to 100,000 pascals or 10 to the power of 5 pascals. More hints. Since the system is compressed, this gas is our system. Because the system is compressed, the amount of work of the system is positive. The work of the surroundings is negative because work is done by the surroundings to the system. The surroundings loses energy while the system gains energy in this process.